We're going to take a look at measuring tools. Now, for the most part, when we're dealing with measuring tools, it's for doing engine work, for instance, and we need to know what the specifications are and what the tolerances that are allowed. So for us as mechanics, when we're dealing with lengths, for a carpenter, inches and foot are fine. We're going to get into, when we get into hydraulics, we're going to get into area and figure out volume. Same thing as with force when we're dealing with hydraulics. But for the most part, what we're after is how do we use these tools properly to make sure we get an accurate measurement. For instance, if someone asks you to go measure the journal of a crankshaft. Now, these crankshafts are usually measured in the thousandths of an inch, and sometimes 1/10,000th of an inch. So we may have 4 decimal points. So we have to know how to use these properly to determine if that crankshaft is still usable or not. So we're going to take a look at just some basic micrometer tools that we can that we're going to use in the shop. So for instance, let's starting with the basics. So if we need to know the area of something, we need to know the width, the height, and the length, and that will give us a volume. Tape measures are handy for what we're doing. For instance, if I have to check the toe in of a vehicle, tape measure works perfect for that because we need to be within 0 to 1/8 of an inch towed in. So tape measure works fine. For doing rough measurements, 6-inch or 12-inch ruler in your toolbox is great, because if it doesn't have to be that precise, then this is adequate. For those that are into the metric system, again, you can get steel rulers that are imperial on one side and metric on the other. Making sure if we have to have something that's fairly close that we measure properly. One of the things I find that if we use a tape measure that, or a steel ruler that's been around for a while, sometimes that first 1/16 of an inch is worn off, so using the 1 inch to start with. Now what about measuring the inside of a circle if all we have is a steel rule? Again, finding the center of the circle and using the tape measure to measure that. Another type of tool that we might see, and now with everything's gone electronic, this is an inclinometer. So we now have digital inclinometers, and this is for measuring driveline angles. So if the driveline angle is too steep, we may end up with a vibration. So when we're going in, and this is third-year stuff again, but understanding what an inclinometer does. A T-square, and a lot of this is we're going to go through. Now as we start getting into, again, doing engine work, setting valves, for instance. So have a good set of feeler gauges and look after them. Now, again, a lot of these feeler gauges are set up so that they are imperial and metric. Couple different types of feeler gauges that you might see is this one here, which is a go-no-go gauge, so they're stepped. So where do we use it? So let's just say you're going to use a lot when you're doing engine work. So if we want to check to see if the head has got a twist in it or a warp, we're going to use a precision straight edge with a feeler gauge to check to make sure that we don't have a twist or a warp in the head or the block. Big T-squares, levels, and calipers for doing quick measurements. Again, these aren't accurate, but to give you a rough estimate of what you're looking for. But when we want some accuracy, for instance, we can use what they call small hole gauges or little ball gauges. And let's say I want to measure valve guides. I can put this in, and what they have is you can tighten this handle up and it pulls this ball up, and you get it so you just got a slight drag on it. And then what you're going to use is a micrometer and measure the outside diameter. Another useful tool is a telescoping gauge set. Now these come in all different sizes, so again, when we want to check something that's a little larger than a valve guide, we can use this. Now there is a proper way to use them. One of the things is, if you have your own set, don't crank these knobs up too tight or you'll damage the inside of this and they'll never work properly again. To use them properly, we're going to put it in like this, we're going to set this, and then we're going to pull it down so it'll allow this to recess into here. Then when we pull it out, it should stay at that, and again we're going to use another measuring device to measure that accurately. Let's say that I have to measure the inside for a bushing. Now let's just say the bushing had spun. Now if the bushing had spun and wore out the journal, then it may not be any good anymore, so we have to know what the exact size is. For instance, they may give you a tolerance of, let's just say 2 inches plus or minus 2 thou. So we are allowed to have 2-inch 2.002 as a maximum diameter. But when we get into accurate measurements, we're going to use micrometers. Now micrometers come in 2 different styles. They can be either imperial or they can be metric. Now the graduations on this, and we're going to go through a few of these, of how they're set up. So on this one here, okay, micrometer thimbles. So if we go back to this one, it's easy to tell that we've got 100 thou, 200 thou, 300, 400, 500, so on, all the way up to 1 inch. These smaller lines here are 50 thou, and these small lines here are 25 thou, and this thimble will be marked all the way up to 25, well 24 and then 0, so it makes 25 thou. So if we take a look at this one here, what we do is we count the full numbers. So we know we have 600 thou, we have 625 thou, plus we have 10 thou and a little bit, but since this only counts to the 3rd decimal point, this would be 635 thou. So when we get into looking at bolts in the next section, there's a thing called thread pitch, is how many pitches per inch. So on a micrometer that has a scale of 25, it's 0.025 inches per thread. Now taking a look at a micrometer, and again a lot of the specifications you're going to see now are in metric and in imperial. There are some offshore machines that the specifications are only metric, so you're going to need metric tools for measuring these. So this is a basic 0 to 1 inch micrometer. So first thing, before we ever use a micrometer to measure everything, we always want to zero it. So we're going to wind this thimble in, and we're going to make sure that the 0 mark is lined up with this before we even start. If it's not, we have to zero it because we want to get an accurate measurement. If it's not zeroed, then we're going to have to do the math. Now be very careful with these. You don't want to damage them, so if you have your own, keep them in a case. The ratchet. So when we're taking and using this, we're going to use the ratchet to get the proper grip on the component we're measuring. So here I have a micrometer. So again, the first thing that I want to do is I want to run it in until it touches. And this here is where I can use the ratchet. Once the ratchets, that's the amount of drag you want. And again, what you want to look for is it set to 0? If it is, then you can use it for whatever you want. Let's just say I want to measure this piece of wood. So I'm going to put it in, I'm going to rotate it, and then I can do my reading. But what if it's over 1 inch? Well, then we have micrometers that go from 1 inch to 2 inch, and 2" to 3". Anytime we have one of these, we also have what's called a standard, and the standard fits in here. And what we're going to do is, this is how we zero these micrometers, because these standards are exactly 1 inch. So this one here is set and it's off about half a thou, so it has to be reset. So we always want to again check it before we use it. The other thing we have is we have a little lock on here. So if I measure something and I don't want it to move, I just turn the lock and it stops it from moving. There's also these types of micrometers that have replaceable anvils for different sizes, and they'll also have a standard so that you can reset them. They are adjustable. So if they do come out of adjustment, you can reset them. You usually get a set of wrenches with your micrometers for making the adjustments. So this is a excuse me, a 0 to 4. So we would have the anvils that go 0 to 1, 1 to 2, 2 to 3, and 3 to 4. And these are the adjusters to adjust the length of them. So you can loosen one off and either lengthen it or shorten it. And again, here's our standards that we get. It's nice to have a set of micrometers that go all the way up to 6 inches. And again, making sure that we zero it. On this one here, the lock is right here. We just turn this lock once it's we have it in position. Again, every set of micrometers is going to come with a tool, so we can go in and we can adjust them properly. And what they are is they're threaded inside here, so when we're turning this, we're actually just moving this in or out. So again, when we take a look at how to use a micrometer, first rotation, again, if we take a look, here's 20, 21, 22, 23, 24, 25. Then we'd start all over again, 1, 2, 3, 4, 5, and so on around till we come back around. So this is 0.025. This is 0.050. When we get up to this, this is 0.200. Now when we get in again, when we're counting, we're going to see the largest digit. So this is, we've got a full 6. So we know it's 0.6, and then we got 25, 50, 75. Plus 15 for 15 thou gives us 0.690. Now there is the odd occasion where we are going to need to have the 4th digit, and the 4th digit is calculated up on the top. So we calculate it normally here. Nothing changes on how we calculate this. So taking a look at the first digit, we can see the 4. Okay, so we know it's 0.4 something, and it's not to the first line, so the second number would be 0 because we're not around to the 25 thou mark. So it would be 0.40, and then what are we at? We're at 4 plus a little bit, and this is where the 4th digit comes in. So we know we're at 0.404. And that little bit, what we do is we find the line that lines up with whatever number here is. And in this case, it lines up with the number 2, so our 4th digit would be 2. Other types of micrometers that you might see have a digital, or a what you would call that? Anyways, a readout. Not a digital readout, it would be mechanical readout. Inside micrometers, and a lot of these will have a handle on them. You're going to use them internally, and again they come with all the different rods to fit inside. So depending on what type you have, this end of this rod will fit in here, and then you use this little thumb screw to tighten it down so it doesn't move. And we're going to put it inside, and if you take a look at most of these, they look like they're perfectly flat. So we have to make sure that when we put it in there we get no movement, otherwise we're going to get an improper reading. The ones for doing holes internally have rounded edges so that we get a proper measurement, because if it's square we're going to miss a couple thou on each end. Another type of micrometer that we're going to see is a depth micrometer. Now we read these backwards to a normal micrometer. So in this case here, we're not quite to the 3. So it would be 0.295. Now if we kept rotating this around this way, it would come up to the 3. So when you're doing depth mics, you've got to remember how they're calculated. Depth mics also have different lengths of rods for measuring different depths. And when we're going to put them in, we're going to put our fingers over each of these sides, hold it down firm, and then we're going to take the top, and if this was it, we're going to run it down until it touches, back it off, and then run it down until you feel it just touch. You don't want to put too much pressure on it so we can get a proper depth reading. So taking a look again at this one here, we're past the 2. We're not up to 250, but we're past the 225. So 225 plus 15 is 0.240. The old vernier calipers, we just don't use them anymore. It takes so long to read them that I don't even teach vernier calipers anymore. I have a set somewhere, but I don't use them. Okay, so dial indicators and dial calipers. So I have a set of these, and again, they're really easy to use. You get so used to reading them, it just becomes second nature, especially if you use them a lot. I have a metal lathe, so I'm always using them for measuring. If you have to reset them for any reason, this dial turns, so you just loosen off this thumb screw and you can turn the dial and reset the 0 mark. And then we get into everybody's favorite. My favorite actually is the last style. These ones here, the digital ones. I never ever took these to the bush with me for the simple fact if the battery died, I'm screwed. I have no way of knowing what the measurement is of something. So that's why I always had these dial ones. I always took these to the bush. So I always had them in the box, and I've got 2 pairs of these around because I used to have so many toolboxes and they've been damaged. Having these around the shop is fine as long as you have lots of extra batteries. Making sure again when we turn them on that we zero it. I also have tape inside here so I can make sure that it's set, and this is 2 thou tape and it measures 2 thou. So we should always zero our equipment before we use it to make sure that it's working properly. Another tool that we're going to see a lot of is a dial indicator. Now we use dial indicators for flywheel runout. If we want to know what the lift is on a camshaft, we're going to use a dial indicator. I have, I think, 6 of them. I use them for everything. So if you find them in a yard sale, pick them up because they're always handy to have. 2 different types of dial indicators as we have here. This is probably the most common one that you're going to see. This one here we can use on a surface that is got some notches on it, just so that the tip doesn't fall in place into the hole. The other thing that you're going to see is a whole set of different types of ends. So this is a set of different tips that go onto the dial indicator, so we can indicate whatever we want. Another style of dial indicator that we might see is a setup like this. Now this one has, for instance, let's say I've got to do the run out of the bearing for a flywheel. Now I never want to use a dial indicator on an angle because we don't get an accurate reading. So what we're going to use is a thing like this, where this can go inside and we can put our dial indicator on that. So as it goes around, how do you explain it? It'll move this way. And with the dial indicator sitting on this with the button, it will give us a very accurate reading of what the inside runout is of that bore. And it's really important when we're doing some of that is to make sure we get the correct runout. For instance, if I'm doing a flywheel face runout, if it's not within the specifications, our clutch could start to grab unevenly. I'm going to put a link up there to a video on how micrometers are made, or excuse me, dial indicators. So the other one is, again, when we get into the metric system. Again, metric micrometers are read differently, and they're usually really easy to tell apart from an imperial one. When we take a look at a metric micrometer and how our numbers come together, we're going to notice that we don't have 1, 2, 3, 4, 5, 6, but we have 5, 10, 15, 20, 25. So when we take a look at how they're set up, they read in different in millimeters. So how do we read them? Well, on these here, the first line, if we go back here, the first line is 0.50 millimeters. Then we'd have 1 millimeter, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. So when we write this down, if this was at 0 right at this 5 mark, it would be 5.0. Okay, and we can also get micrometers that are metric sized. So the next few are just things to go through. So again, I don't know how much you guys have used micrometers, but we're going to go through and take a look at a few of these and see where they're at. So first thing we need to know, what is the first full number? So the first full number is 3. Then we have 25, 50, and 15. So if we take a look at it, it's 0.365. So I'll get you to just go through the rest of these on your own, and then if there's any issues, then we can actually get some in the shop and go through some of these. I'm just going to skip ahead here to the end. So another thing we have to know about is a thing called torque. So torque is a twisting force, and we use this, for instance, if we have to torque a bolt in place. We'll use torque in a couple different things, but how do we measure torque? Well, for us in most cases, we're going to take a torque wrench that's already preset. We're going to set to 350 foot-pounds, and we're going to torque it till it goes click. But there is a formula for figuring out torque. And how we do it is our length times our weight, our lever. So if this is 12 inches and we have 1 pound of pull on this, of a weight of 1 pound, we have 1 foot-pound or 12 inch-pounds. If we have a lever that's twice as long, then what do we get? Torque wrenches come in a couple different styles. Click style, you're probably the most common that you're going to use. There's the beam style. So before you can afford one of these, you get one of these, and I have one. The other style that you might see is a dial. And this is good for doing what's called rolling torque. if we want to know how much force torque is required to turn something and keep it constantly turning, we can use a dial type. Now, what about if we have to have an extension on the torque wrench? So here we're making the torque wrench longer. So this is the formula that we use for the torque wrench. So it's the wrench setting, so let's say it's 100 foot-pounds. So the desired torque times the wrench length divided by the wrench length plus the extension length. So again, what we want to have here is the desired torque is 180 foot-pounds. So we're going to multiply that by the wrench length of 18 inches. Then we're going to divide it by 18 inches, the length of the torque wrench, plus the 6 inches for the extension. And we end up with a setting of 135 foot-pounds because of the extension. So if we take, and again, I'll let you go through these here and take a look at it, and if you have any issues, we'll discuss it the next day or in the shop. Another thing we might see is what's called a torque multiplier. Now, torque multipliers come in 3-to-1 or 4-to-1. So the most common I've seen is a 4-to-1. So let's just say I have to torque a U-bolt up to 1,000 foot-pounds. Having a 4-to-1 torque multiplier, I only need to use the torque wrench up to 250 pounds because it's multiplying it by 4 times, which would give me 1,000 foot-pounds. So what we gain in being able to torque up, we lose in our travel that we have to pull. So to torque something up, it does take quite a while. There are also hydraulic torque wrenches out there, or torque multipliers that we can use, and they're preset on the gauge of what the torque is going to be. For those fishermen, you'll probably recognize this. This is a fish scale. Now, we use fish scale for doing rolling torque also. So let's say the most common thing we're going to use is if we want to preload a pinion on the rear differential. We want to know what the rolling torque of that pinion is. And so we're going to use a fish scale. Now, when we're doing rolling torque, it's not the torque that it takes to break the bearing loose and get it to rotate. It's what it takes to keep it rotating is what we classify as rolling torque. And this is how it's set up. So here I have my pinion set in the press, and I have the press pushing down on the top bearing. Now there's a spacer between the two bearings that give me my preload. So I'm going to wrap my string around this 3 or 4 times. I'm going to put my fish scale on there, and I'm going to give it a pull, and I'm going to read it as it's pulling a nice steady pull. You'll be able to see. And let's just say that the specification is 5 pounds. So that's 5 pounds of rolling torque. That's the only calculation. You don't have to do any other calculations. But what if I wanted to calculate rolling torque? Well, there is a formula for that. So first, find the diameter of the wheel, divide that by 2, and this will give you the radius. Calculate the force required to rotate the wheel. The formula to use is pounds pulled times the radius of the wheel. So if the wheel is 1 foot and the force required to rotate the wheel is 10 pounds, then the force required is 5 pounds of pull. Okay, so again, I've got some things to read, so go through this one, and that one.